Okay, when I welcome, good evening, all of you. I said make I run today's show for Pidgin English, as a matter as a beginner. So sometimes you go try to explain something, but it's either you way they speak and not they speak and well, or the person way they try understand, not they understand the thing well. So I just feel say today make I run these matters for Pidgin English, and then we could just know what they talk about, what they try do. Um, that is for that for now. So what I go try do today be say I go try run the start, stop and the reset button. I go try program am. So what I go do now be say I go program am with ladder first, and then when I don't program with ladder logic first, then I'll come show the same thing with what do you mean the name structured computer language SCL. So you can just see how much these things be. So sometimes some people go say, okay, why they prefer SCL? Some people go say they prefer ladder. But I just want to show you through this video, say, really, not be one stone they kill every bird. Not be one thing they actually fits into every particular problem where you get any programming language. I mean, so you know, could just come like this and say, okay, now because say you know SCL, then you go dey okay for everything you want to do. No, sometimes you go say na ladder dey better. Sometimes you go say na SCL dey better. But whichever one you prefer actually, programming language na programming language. But for you not to just die for the matter, for you not to just quench inside the inside the matter, you get as it be now. You go try to do one thing without programming language. You go see and say it's very difficult. Without wasting much of your time, let's just go into the matter and see how the things they be. Okay, remember, what I want to be say, if I press start, I want this thing to show, right? And then if I press stop, the satellite will go off, and then the red light will come up. So when I press start again, I'm not going to start until I reset. If I reset, the red light will go off, the yellow light will show on. Then I'll press start again, the yellow light will go off, the green light will come up, just like that. So okay, today I want to use CPU 313C, right? Now TI port with this one. So TI port TI means totally integrated automation, and Siemens and I get the matters. Okay, so because I know something I just want to do now, start, stop, and reset. Now just digital signals. It's either it is there or it is not there. All right. So I don't even the mix English for the matter. But I realize are good for this English matters. Yeah, leave am. So okay, what thing I go do now be say I go change because if you come here, if you see what we'll get here for this scenario, this thing what I want to work on. If you go to file, options and drivers, this is now actually tell what's in the name, FactoryIO, right? You can see the name there. So if I go for file drivers and then I go for PLC sim, right? I want to simulate this thing with PLC simulation. You go see, say, okay, this things that already connect them for some addresses. Yes, I will still change the addresses. I will still remember what I want, but I want to maintain this particular thing we done there. So what I just want to work with now today now start button. These are the input side, right? This one will be the input side. Then this one will be the discharge side. I be the output side rather. So this one will be my start button, my reset button, and my stop button. This one will be my start lights. This one will be my reset lights. This one will be my stop lights. Okay, so what I go do now be say I go just go for this one, and then because say now digital signals I want to work on. Remember one of the things I know show you here now be say this one there for I 0.0. Remember we don't talk say before. Say I means input, and then 0 means the 0 byte, and then this other dot 0, the 0 after the dot means say now bit 0 inside the byte 0, right? Why this one a bit 1 inside the byte 0? This one a bit 2 inside byte 0. And the Q here means output. Actually, I know some of my homies could especially this in O, now 0, or O rather. So instead of O here, there's an Q that like. So Q here for output. So anytime we see Q, just also they will talk of output. So the same thing here, output byte 0 and then bit 0. So this one are byte 1 of, bits 1 of byte 0 of the output uh, card, right? Okay, so what thing I go do now be say I go for this one. Since I don't know say all my bytes one work for the input and the output now byte 0. So I got to click on this one, which is my I think this one is my output card. So you go see I'm there saying a DI/DO, right? DI24 DO16, right? DI24 DO16. This digital input 24 bits, this digital output 16 bits. So I go just right click on them and then I go to properties. So when I go to properties, hopefully it opens quickly. Maybe I said it's in the try get himself. You know, say, you know, as a matter as the being, only that way don't start this kind of thing like this most times for this program. You go, the system go on first adjust to what they do before. Now start ACM. I don't know whether any grammar be like that to actually support it at the talk. But the truth of the matter is say this one under the input address. So for this input address, so now what I go do be say you go see say by default I get byte 124, right? So I know like this, I know 1 byte 124, if not you know go work. So I want byte 0. I want byte 0. So if I don't do this byte 0, I go press enter. May it start from byte 0. Of course, system 24 goes end for 2, right? So 0, 1, 2. I expect this end address to be at 2. So you see the boot itself. Okay, so because there are 8 bits, we'll get 8 bits inside 1 byte. So if DI tell you at 24 MB, so 8 bits inside byte 0, 8 bits inside byte 1, 8 bits inside byte 2. So now so we'll take the 24. Okay. Alright, so for the this one for the input side, I do for the output side now. So for the output side again, we still get byte 0. We still get byte 0. So byte 0, that's what the matter does take, it goes end for 1, I think, because this one has 16, the D one has 16. So it should end for 1 because there should be 2 bytes in 16 bits. So I think, okay, so I could just save this one. I go save this one, and then I go compile them. I will compile and the things they compile. Just exercise more patience with me. This particular one, I don't know. I know. Say when I don't do so much, the thing go, it go stop to the delay like this. So, but just hold on a bit. So checking consistency and every other thing we want check. This one actually in a basic program for so many of the things we you go see going forward. But I just make I do them, of course. Even Bible, even the Holy Book talk and say, if the foundation be destroyed, what can the righteous do? You know, as the matter has been. And if you know if you don't get the foundation right, if you don't get the basics right, then no matter how much you climb, it's just a matter of time before you fall for ground. So now make I try to do this one. At least let's create a very good foundation, so that anything we see tomorrow, you know, will just be like say, with the build castle in the air. Okay, so the next thing I'm supposed to do here now is say I will start my simulation before I actually download this program. So I will start simulation because again I know they're connected to any live CPU. So I want to simulate this thing. Now make I choose PLC sim when I go for FactoryIO. That time, you remember when I'm in day here. Sorry. So when I'm in day here, I'm in come to Siemens PLC sim, right? Because na simulation I want to do. So I will start this one, and then I expect and say it go download by itself automatically. Make a pause and immediately download finish. I'll continue. Okay, the thing does show me reach this place, so I will just load. So I will just click on finish. Okay, so the next thing I will do now is say I don't already set my device configuration. I don't do my device configuration. I don't set my system how it's supposed to be. So I'm waiting on one use work. So the next thing I will do now is I will go program blocks. When I go this program blocks, the next thing I go do, make this thing where now. So I always tell you say there are two ways you can actually do programming in PLC. You can actually do it structurally or you can do it linearly, right? So instead of me to just come here, come they write everything inside main OB1, I really like to do like that. I know so not be the proper way to go about this thing. So what I would do be say, if you have a very big program where you want write, a very big plant where you want do programming for, you know, when they write everything inside, you go there too clumsy now. You know as the things they be, you go there too clumsy. So if issues there for one place, you know, go fit just come resolve the matter. So what I could do is say, I will come for this add new block. I go double click on add new block. So because I want add a new block actually. So the kind of new block I want add here now function, right? You go see now function. When I start SCL, right? You go see me use another kind of block. But for now function I want use. So if I click on this function, what I want write now I want call them might just call them start, stop, reset, right? If you still give on that name, start, stop, reset, no issues. And the language I want to use write this in now ladder. Remember I thought say when I use ladder finish write this in, the next time I will use SCL, structured computer language. Okay, so I go say okay. So when I do okay, I expect the start, stop, reset function to open for me. Make I pause them so when they open, we'll continue. Okay, so the function not open for me, you can see it here. So now start, stop, reset, FC1, right? Computer don't call them FC1. Of course, we tell them to name them automatically. So this is the first function, right? Function 1. But I don't give them name of start, stop, reset. Remember, say them be the name of the project, what they also do. So what I will do here is I will come for this, they call them block interface, right? So I'll come for this place, open up this drop down. So because I want to declare my variables here now. So because if you look here for this FactoryIO, you go see what you get here. Now actually you get your start, stop, reset, start, reset, stop, and then start lights, reset lights, and then stop lights. So now these 3 inputs and 3 outputs I really want to work on. So what I'm going to do is I want to declare all of them as input and output for my program. So what I'm going to do is say I will go back there. For the input side, I will call start. So if you see start, you know say that one be that. So the data type actually in a bool. Why it be in a bool? They say you can only get only 2 things in the field do. It's either you press them or you don't press them. Right? It's either in the pressed or not pressed. If you know if you press and small, it's either in talk say oh, you don't press them, on talk say you don't press them. So there's something like say you don't press and small or you know press and small. Press na press. No press na no press. You get the matter. You get the matters now. Okay, so the next one reset, I think so. And then I see the same thing. All of them are push buttons then B. And then the other one now stop. So we'll get start, reset, and then stop. And then all of them are bool, right? No, forget about all these ones with here for now. This offset, default value, and this. I don't want any default value. I don't want. Yes, if you put comments, actually, if you come here, I say this is the input button, this, but all those ones you go do them by yourself when you don't sabi what they talk about. Okay, so for here, the output, I need to see start light. And again, it's either light show or light no show. Then make I go leave them for the other type of bool. So it's either light show, light no show. So even some people, I hear somebody they talk of half current. No, nothing like half current for this one. If the current they have, then it means say they show, right? So if you know they show, you know they show. If they show anything at all, then it means say they show, right? So this one are actually true or false matter. So if you say the next one will be reset light, and then the final one will be stop light. So exactly how we see them for that place now we just do. But I will show you something for all these things we just do now. Alright, so I don't declare them. The 3 input peripherals I want to work with. They call them peripheral actually. So because physically they exist. They get. So if I go for field now, I go locate those buttons. So now we call them peripheral. So this start, stop, start, reset, start light, reset light, and stop light. Okay, so what we go do here now be saying, if I come here, I go press this, I want to start the programming. So for this programming, I want to do is start light first of all. So if you come here, don't say this is your start light network, right? This is your start light network. So for this my start light network, I want the solution to be say if you press the light, right? And they call this normally open contact. I be no one follow me come. Okay, so I call the what's the name? The normally open. Why they use normally open here? Because I feel switching to normally close. If you want, you can always change. If you change anything you want change from this, you see this small orange button, orange icon, I'll be symbol where I click there. So if you change them to normally close or this is normally open. But what I want leave for normally open, we say you know it's a start button. So first of all, you see this place who did like this now, we call on um, the power rail, right? And then this horizontal line, this vertical one now they call power rail. And then this horizontal one, where I put this normally open now, now they call the element wrong, right? The wrong. So something that happen here now. My signal, my power always dey here, right? So now, because say everything I want to do here now, like a logic I want create, we go actually turn on an output or turn it off. You get the point. So waiting go there now be say if I come here now, I will select this one as output. If I select this one as output, um, if I select this one as output, now waiting there now be say, I say whenever signal go on, power go on flow from here, come this place. But because I don't put normally open here now, you go see say no go fit flow. So waiting go happen now be say, you go this one go break the flow to this final one, this output. So but whenever this one closes, anytime when this one don't close, so meaning say anytime I press on for field, right? Or I press on for this factory, you know, it go close. And immediately it close, remember how they call and start button. Immediately it close, I expect say this thing will just pass through and then come to this one. And again, I want this one to be the start light. So what I go do be say, since I don't already declare them, I'll call this one start. I'll call this one start. And then I go call this one. So I'll call this one start. And then I'll call this one start light. Now you go see what I go do here now. So I don't call this one start. I don't call this one. I don't call this one start. I don't call this one start light. So whenever I press the start, you go close this one now because they open already. So immediately you press them, you go come here, come give light to this one. Someone just says what we don't do so far. So I go save. I go compile. Now, may you know say what you just create now a function, right? Now a function you don't write your program inside. But PLC, the way this PLC they do, they say you know go just say okay because you don't write your program, no matter how beautiful, no matter how lengthy, where this your long, where this your program be, you know go feed, you know go agree run them until you call them inside the main OB1. Since the one we open this thing, we not create this main OB1 waiting for here now. So this main OB1 you must call them inside because this main OB1 get work. In work now say now in they actually execute everything where you put. I don't go to talk of execute. Now in they actually make everything the work, right? Waiting for your where you write here now. For example, if I open this main OB, and even though I don't go create this start stop reset function, if I no call them inside main OB1, it no go work, right? So now so the PLC they be. You go see say maybe you need to, oh, I go take this years from the basics like this. You go find out say this is be the one of the major differences between your PLC and your DCS. But more leave DCS matter. So now you go see say main OB1 they open. So if I drag this function, I put them inside main OB, right? So that it go know the main OB actually. Make it just see what thing go happen here now. So what thing they here now be say you see say all the things we call input, now then they as input here. All the things we call output, now then they as output here. So this thing they ask me to make I link them to the physical world, to who them be, to the buttons actually. So what thing I could do here now be say I'll come for this one where they call PLC tags. I'll come for this one so they call PLC tags. And then I go open this default tag table. We'll just use default tag table for now. So if I open default tag table, all this is where they slow like this. Okay, so for this PLC default tag table, I want list all those things I list before, my inputs and my outputs. So I go call this one. I think call a start button. At least make just see any small. I think they give her the same name of start. We might just call a start button. Again, the data type we don't already talk before. Say na bool, right? We don't already talk before saying a bool. And you see this address here, the thing just come enter for I0.0. If you check for this your FactoryIO, you go see saying actually I0.0. Not be because of say the thing know what FactoryIO they do. No, now just by luck. I don't want to say by mistake. Now just coincidence. Now we this one just take on become I0.0. But if not, we will still change about ourselves. But we'll see another one we go change. The next one reset. We call a reset button. And then the other one stop button. So reset button na I0.1 and then stop na I0.2. We'll see what I say be reset I0.1, stop I0.2. Okay, so you see here now, I want to here I know they do say input and output. You go name both input, you go name both output, you go name both memory bit, everything. You go name them inside here. So this one they select this PLC tag table. You need to select whether na input may name input one side, may name output one side. No, you go name everything, both input and output. In fact, if you name one input, name one output, name one input, name one output. You know they select, you know they tell me if they wrong or problem they no, you know they do like that. So this one, the next one now will be start light. Right? And this say if I put start light, say this is not going to continue for I0.4, I0.3 rather. So but we also not be I0.3 because if you look here, now actually Q0.0, right? So instead of that, I go open up this thing and then I go change them from I to Q. So the operand identifier here supposed to be Q, not I, right? So if you wonder within this MB memory, right? We'll come back one of our examples at the station, so we'll go treat them. So the address here is 0 and the byte here is 0 and then the bit here now also 0 as we just see. That's Q0.0, now it will be so now. So the next one here, we like to follow the same line. So now reset light. So you go follow Q0.1 and then we'll get stop light as Q0.2. Stop light as Q0.2. If you check here, Q0.1 reset light and then Q0.2, then be your stop light. Okay, so you don't do these things here. The next thing you just need to do for yourself, now to come for this main OB, right? If you come for your main OB, you need to actually start to attach all those things within these ones then be. For example, I don't name start button, so I go call this one start button. So immediately I put S there and then go bring out everything we start with S for me. So I know saying a start button supposed to be there for start. And then for the reset, I know saying a reset button. For stop, I know saying a stop button. For start lights, I know saying a start lights there. For this one, I know saying a reset lights there. And then for this one, I know saying a stop lights 9 there. So you see how I don't attach all of them now. Now the first thing we will do now to actually write the program inside our function, and then before we actually come for OB1. So if I save, I compile this thing. So the next thing for me to do after compiling this thing is to just to hit the download. So I'll go check this one, download to device. Of course, I want them to download to the device. So I'm making overrides in another thing where they there before, in case they are the same. Okay, so now see the code we write before. I'll just want to show you where we deal with the code. All those things we will do, we're not going to do them again, right? We don't really do them once, now once and for all. If I come back to my FactoryIO here, I will just hit connect. Why I want hit connect now, I believe to go connect because see my simulation is already running here. If you see here, it already did for on P, right? So I will just hit connect. Immediately hit connect and then connect, you can see this green check mark here, right? To show so you don't actually connect. So now if I press play here, so anytime I press this button, I'm supposed to see the light, right? But if it's checked, I don't press and hold them. So if I leave them, it go off. If I press and hold them again, it go come on. So if I leave them, it go off. So it means say I never really finish waiting there for this place because now push button be this. So anytime we leave, I'm gonna go back to open. I'm gonna break the signal we're supposed to come here. So what thing I go do now be say the right time I will come put latch. So for me to latch this thing, you don't hear latch, but you don't see and say here would they actually use latch. So see what's in the click. I want to branch this network just beside this one. I want to create an alternate of this one. So I will create a mask with normally open, and I will tell you why they use normally open. So I go use normally open there, and then I go close the branch for here. So what I go do here now be say, you get start. What did I be say? I go put this start light for here. Right? I go put this. Remember, say the start light. If I clean this thing, the start light what they use, not be this start light of we get since this not be this start light we get Q0.0 here they use or no. This one already one place where I go use all these ones so get addresses. Now for the place for the main OB1 for the main OB1. Every other place I will use this one so we get this pound sign, this hash sign, right? So now be the local variable, now be the one where I create inside here, now be this one here. So I they use this output, they create an auxiliary on the input side, right? So I go create start light here. So now what I try to do now be say, if I press this start, it could just go give this one, right? And immediately give this one, everything will get this name start light go change state. So this one and I open, it go close. Even when I remove my hand here, the signal go follow through here, they go to this one. You understand the point now? So even when you don't remove your hand for this one now, the thing don't get another rule don't go follow because this one that first time we press them, will this one come on, don't activate this one to close. So if this one close, even if you remove your hand here, remember so I tell you say signal power always there here. So you go just follow here, they give this one. So move try what you don't do. And actually some of you they wonder what to make this yellow light, the yellow color there. Yellow color there because of say the what's the name? Now I declare this thing as output, but now they go and use in name also as an input. So they give me warning. Say this is what I declare as output here. You don't still use them as input. Now make you get something like in out. So now make I say I go show you something here before. I don't know that you still remember when I thought say I go show you something here. So actually I feel cut all these things, put them inside in and out. Right? So what I go do now be say I go cut all these things in case you don't like the warning sign. I'll cut all these things and then I go put them for in out. So these things I use them do latching. So they are not just proper not only output to them be, they also get auxiliary, so they also input. So you see, I don't call them as in out. So you see that your yellow warning sign don't go, right? So now so it may be. So if I save this thing, compile this thing, and then if I download them, if I download this thing, load, you go see say now it's supposed to done the hood. So if I go there and I press this one, this green one, I just press them. See my cursor, right? I don't leave them, so you don't hold. In case you want to see how this thing take the work, you get this thing where they are called monitor. So if I monitor them, you go see how the signal take the path. You go see say the thing know the flow from this start button, it actually go through this one. We just wait for them small, make the thing come. So as you go see here now, you see say actually the signal they follow through this place, they come here because your hand don't come out from the start button. So you see where your signal they follow pass, they come here. So now so the matter just be. So for this one now, I don't do the start. The same thing I go do for stop, the same thing I go do for reset. Before I start to create interlock so that I go know which one go stop which one. Move first finish those other simple ones, right? So I go stop to monitor this thing. You go ask me whether I want to go offline. If you want to go offline, you can go offline. If you don't want to go offline, you stay online. You will still go online again. Okay, so this one are for your start network. For my stop network or my reset network, no matter the one we want to do next. So if I want to do reset network, So for this reset network, just the same thing what I do here. You know, see the reset now still the button are normally open, just like the start will be normally open button. So I go still use normally open contact here. No go to say normally open means for normally open button means say we use normally open contact. Nobody that's way they actually work. But for now, we'll just freestyle this one, they go away. So I don't get this one here. So I go put this one. And then the next thing, I go need to latch them, of course. I don't need to show you within how this one go be now because you don't really know how it will be. You could just the on the off if I remove my hand. So I need to latch them here. So this one go be your reset. Remember I said that the one with the pound sign, now with the collect so. So here again, I put reset light. I mean my output. And then for here, I also need that same reset light. Right? So this one will be your reset network. And then for your stop network, this one they somehow sha. So for your stop network, waiting there here now be say I go use if I bring this one for stop. Remember say your stop button a red button, right? And a normally close button. So because in a normally close button, you don't really send signal to the contact where the thing they connected to. So how this thing they stress my life now. Huh? I hear somebody they say, "Ma go buy new laptop." My brother, maybe waiting naira and dollar they talk now. Go take go buy new laptop. So okay, if I go for my stop, now my stop because in a normally close button, red button, the don't if I connect here now, it don't send signal here already. So if I put stop, see now. If I put stop here now, and then I put my stop light, so it will happen. And then I put my stop lights here, so it will happen. The red lights, because in a normally the red button since it's normally closed, you don't you could just close this one and signal go to pass here. I never press stop, and yet I don't get red light to show you I did stop mode. So what I go do with that is say I go change this one to normally close, right? So that when as the signal they come here, we don't they come already without me even pressing this thing. It go open up this thing, so signal no fit come here. If I leave it for open, it go close am, signal go come. So I hope say you understand that you understand the check for there. So what the next thing now I say I go just latch them, just like every other one what I don't do before. I go latch them, and again this time with normally open. So this your stop light, right? Stop light, your light no dey for normally open or normally close. Your light now output. So you know they do normally open or normally close. Now no input and they do those ones. Okay, so I don't finish these things, and if you see what's that happen here, if I save, I compile. I download. So if I save, compile, download, you see, so if you go back to your FactoryIO, if I this one they here now, of course, even if I press them, you know they stop, you know they come out. So if I press this one go come up, nothing go one stopper for now. So if I press this one again, see say the three lights just they on like that. Of course, we know say no plant they work like this, no panel they work like this. So what we need to do is say now here we need to create interlock, right? Which one will go stop the other one? So remember we thought say the stop light go actually need to stop the start light. So whenever the stop light they on, I won't stop the start light, right? So for this start network, I go just come in for the along the road here. When I don't after this whole logic of this start light, so I go put a contact there. I go put a contact there, which I go call stop light. Okay, I don't put this one here, but this one need to be normally closed. Huh? You don't need to be normally open. You need to be normally closed so that you go there close. The only time where this thing go open now when the stop light don't they on, right? When they stop the red light they show, this thing will just open. And immediately you open, it go break the pathway, the signal we want sent to this start light, right? Or we don't really send to the start light. for this reset one, when I want the reset light to go off, now when this the start light they on, right? So here again, still normally close, right? So for normally close here, I go do start light. So anytime we start light they on, maybe you just open up and then you go break the signal here. And for this last one, which is my stop network, what thing I want to do, the only person who fit stop am na the reset, right? So anytime we reset they on, make you just give way. So see how I don't take create interlock for all of them. We'll see whether waiting I do. Excuse me. We'll see whether waiting I do, they actually work. Like I know they are the smart they go. But I know say it will work finally. I know be today person for this matter. Not mind me, sir. They say if lizard fall from tree, come down, person no praise, I ain't go praise himself. Okay, so the next thing I will go do here is I go try these things. Is this say okay, based on what you don't write, the other one's not off. Now this one they on. So but we agree say if I press this one, this light will go off. So I go press this one. If you say this yellow light don't go off, him don't come on. If I press yellow, nothing will happen, right? If I press this one, nothing will happen, the green itself. If I press red, I'm going to stop this green, and then I'm going to show say the thing don't stop. And then if I press start again, it don't go overwork until I reset them. If I reset them, then I feel press this one. So all those things where don't they see where they work, the way with just like this way they work, now like this and take one, right? But this one now with just ladder logic. No be na ladder logic. Yes, we fit do this thing with every other program language, but this one I just show you now na ladder logic. The next thing I want to do now say I go use structured computer language SCL. Make I do the same thing. Make you see how the different programming languages they actually operate. I go get back to SCL now. Okay. So I want to repeat this thing now with SCL, but I just make I show you what I do here. I don't click on add new block. So inside here now, I use function block, and I will tell you why I use function block, right? And not function. Remember, someone will do the same for ladder here now. I just use this function. But now, if I use this function, it no go ever work, right? And then I want to use this thing for function block. So for this function block, I use I don't give them SCL start stop reset, so you can feel know the difference between this one and the SCL. And the language I want to use here na SCL, right? So I want to use SCL. So I will just finish every writing, keep them to the place where we will feel know what we don't do, because I don't want to do repetition, make the video not just over long they go. Okay, as you go see here now, I don't create the SCL with the function block, and then here I don't name all my inputs, I don't name my output. But they get another thing I name here for static variable. Actually, if you open your function, you don't ever see this thing called static variable, static, right? So that be the major difference between the function block and the function. Now, see what in function block, this static variable they do for this function block. This static variable, they help give this thing memory, right? A reserved memory. Memory where this thing no go just throw away anyhow, right? Something need to overwrite them before you go actually come out. So in the update itself to new values, in there they just go, not be volatile something. In there they just disappear, right? So remember why they use this thing? They say when we just do the waiting the other one name now, ladder logic. You see, say I needed to latch, right? You see, say I needed to latch the thing. So because of that latching, if I know actually do something here, we go feel retain this signal for me, my brother or your number by name. So what I go do now be say, now make I don't name all these things here, and if you see the name I give them start light 1, reset light 1, stop light 1, just because I want to give a different name kind of from this one. So that anytime I see start light 1, I know say it relate to start light. So but this one now for a static variable, whereas this one now be for the proper output, what would they actually look at? So I go do that thing now. Now this one be the normal kind of coding. I know say most programmers will like this one now, right? Most of these programmers where they outside, they will like this one. So actually then put this one so that you go easily come into this automation line. In case you know this line before, if you still just enter this automation line, then no say this will not be new thing, this will not be one big thing for you we don't really sabi programming language. We don't sabi one programming language or the other. And this one is version 16, I think version 17 even get Python. So if you sabi Python, if you even run these matters as it be so. So for this one, now SCL with the right. Okay, so what I want to do now be saying, I go use if else statement, right? If or else if statement, as they always talk about. So what I go do now, I go say if you press that start button, right? Remember, say I don't declare the start button for here already. You go see, you see I'm already for here as input. So if you press that start button, and remember, because I don't already declare them before, I will just say start. If start, remember say I thought the one will get the pound sign, no be this start button. I feel just be say, okay, why the feel three different now be say I name this one start button. What if the site just call and start? Maybe if I confuse you, always look at this one and know whether this one get whether the global variable be this one, whether the physical variable name be this one. May you know carry this one put for here. It go still work actually, but not be the proper way to go. You could just confuse at the end of the day. So if start, right? I just say if start. This if start just be like I say if start is equal to true, right? If I just say if start, I feel say if start is equal to true, I feel say equal to 1 or equal to true, I feel still write like that. But all this one not to just waste my time for something will be the same thing, right? So if start and waiting again. I want the rate number 1 on this thing. What I want on this I remember saying the green light I want on so now. So if you don't press the start button and before you go press start button, before you go the start light go show, you know say yellow light go first the show. Right? Yes, from the example we'll see here, and I'm gonna show you again. Another spoiler. So if I press stop, if you press start, it no go ever work. So at the press if start button now, see at the press start, it no go ever come. So the later we go come now say this yellow light stay on, and then if I press this one, now it go actually work. So I feel still leave am for only that one, but again, I want to make sure say I won't make this thing tighter, right? Make it not just the loose kind of. So I will say if start, now you press them, and this reset light, and this reset light, right? And this reset light is equal to true. I go just leave it like that. And reset light, right? So I go say then, in case you will know what kind of thing for head, may not be like that they are the form done for this matter. See the template here. If you just click on this one, if you will give you everything where they are the right. So why they do like this? Because say I don't submit this thing, I don't the right time since. So in case you know cram this thing for your head, you don't need to cram them. The people who do this thing don't really keep this thing for you here. So make it just right and they go. You don't need to cram them. So if start now true and reset light they on, then I want you to do something. So what's that thing I want make you do? I want make you do reset light. Before we talk of reset light, okay, may I first talk with you now the one way they clear to everybody now. So I want to say make start light, right? Make start light, but instead of start light, I want make it be start light 1, right? So I go say make start light 1 because I start light 1 I have my static variable, right? I have my physical, my latching variable. So I go say start light is equal to, I dey give them this thing. Since I go take put on now, sorry. So I go put colon with equal to. Now so you go take make them say. Now so you take assign value to that. So now I dey assign a value of 1 to that. Then I say make you be true, right? Make you be true. And remember say I must end them with semicolon. We both must send a semicolon. Now my brother semicolon anyway here. Just take it like that. So the start light 1 now they actually pass the value of 1 to. So and I know say you go retain this value. You know go give them out. The guy is stingy as far as you don't call him a static variable. So the next thing I want to be say I want call reset light, because now the reset light go there on that time now. So reset light 1, I want pass the value of 0 to that. Right? I want pass the value of 0 to reset light, And then, so what I can do now, I can say start light, which I don't really say now my output now. So now my start light now, I want make them equal to, right? I want make them equal to my start light 1. Don't go right start. So now be equal to my start light 1. And my start light 1 here now equal to 1. Somebody go say, bros, why you not just carry this one, put for this start light instead of all this long grammar way they do? If I do one like that, you know, will give me what they find, because you see this start light 1. Remember, saying I'm be my static variable. Now I'm going to hold this thing for me. This one, if I just do like this, you know, go really give me the kind of thing what they look for. So if you try by yourself, shall later. So start light 1, now I'm be I don't make my start light equal to start light 1. Somebody go say, why start light 1? Why? What if I say start light 1 equal to start light? Say, what if you say start light 1 there and I'm be equal to start light? My brother, not be the same thing. So are they actually not say for programming? You actually pass the right hand side to the left hand side. So the value waited for this right hand side, now they pass to this left hand side. So start light 1 now they make equal to now they put inside start light. I think I don't explain that one. So reset my reset light. My reset light now I dey make them equal to my reset light 1. I dey make them equal to my reset light 1 with my static variable, right? So now what is the next thing? I don't do for this one, I don't talk wetin I want, make it happen for this place. But some of you don't see this thing, and not say you feel the scratch your body, say, why this red light they show me here? Okay, we just remove this red line. Why they show me there? Make we just remove the red line. So for you to remove the red line, you go say end if, end underscore if, right? So end underscore if, don't forget to terminate them with your semicolon. You see, I say the thing don't go. Okay, so inside here again, I still want to write another condition. So this time, I know they write a condition will contradict the first one. So will be direct contradiction of the first one. So I will use else if, right? So I say else if, and remember say the else, you need to complete the grammar. C as B, ELSIF, right? So else if not be what you do for the first lines, maybe what you do now this second one, you say the reset, you press reset. Maybe your reset button, you press them, and before you go press that reset button, when you want press the reset button, may work. You know, say the red light they show Abby. So and stop light. And stop light. So if these two conditions they met, then I want to talk what thing will happen. What thing be the thing I want may happen for that place. Now be the then part. So then I want you to actually might just copy this part. If it make life easier for me. I don't go cut everything. Now Control Z I go press. Control X now I go press. I think I just need reset. I'm gonna copy everything. I go come out the ones I don't need. Control C. So I go V there. So here now, you see say if you press the reset and then the stop light they on. So what I want to do be say for here I want make your stop light 1 make you go 0, right? Make your stop light 1 go 0, and then make your reset light may come 1. You know now, because you don't press reset, so you expect reset to see reset. So for here, I want to see here supposed to be stop light. So stop light is equal to stop light 1. You understand? So anytime we press the reset button and the stop light they on, I'm go stop this, I'm go send 0 to that static variable called stop light 1, and then go send one to the static variables where they call reset light one, and then would they say make your stop light equal to stop light one, and your reset light equal to your reset light one at this condition, right? So the next thing we go do is remain one, right? So that other one we want do so. I feel just copy this part. Don't mind me. This to write something, I need to like need to like to write to repeat something I don't write before. Okay, so for this one, your stop, Abby. Now we never do so. Yes. So anytime where you stop, anytime where you press the stop button, and your start light they on, and your start light they on, then what I want to be say for that my stop light, I want send one to them, and then to my start light, so I'm gonna be start. To that start light, I want send 0 to them. And my stop light, I send to stop light 1. Okay. Then this one reset here gonna be start. Start light, and then this one here go be okay, start light. Okay, you don't see how this one be, right? So it all depends on you how you want this thing to be. Move first tester before I start the sharp math. So I go save this one, compile, and make you know say okay, I go show you what I want to talk about now. You see this main OB, because I don't already name all those things before, I don't need to name them again for PLC tag. I know come there, they already did there. So inside this main OB, the one with here and I see start, stop, reset, right? So I want delete them with my ladder logic. So I want put the one we carry SCL. Why they delete them actually? If you still leave the two of them, but different things feed it for OB1. But why they delete them? They say they're going to interfere with each other because they're the same addresses I use, and they won't show you different things, right? If not be this one, maybe this one. Okay, so I want carry this one, put inside here now, the SCL one. But see what thing gonna happen. You go ask me for a data block, right? We call them DB. So we may just tell you say SCL start, stop, reset DB in need them. So of course, okay for them, a database, a data block, whichever name they want give them. So of course you need them to take hold all these things where all these properties, features we in carry. No problem. Now so the function block they work. So start now be your start button, right? We don't really know that one before. Sorry, I don't go put start light for here. So this one will be your start button. This one will be your reset button. This one will be your stop button. This one will be your start light. This one will be your reset light. This one will be your stop light. So most see whether for you to see, might show you something. If I save this thing and I compile them, although I never did download them, but if what I do know the work, you know go work the same way the other one they work. Okay, I make one error. Might show you see this thing. Don't be that former one where they work before. So because some people now doubting Thomas. So I go save this one. You see, I just put reset light 2 times. So I'll show you see now the updated program now in the work, so no be that former one. At least we don't know say the former one who use that logic right. It they work. So I want overwrite and download to device. So if I go back to this one, I don't need to connect anything. If it stop start, make I reset this PLC because of course from waiting I don't write, I don't need to see this one. So make I reset this PLC, I stop, I start. So now I don't reset them. The thing don't clear for the memory. So you see if I press this button now, I'm not supposed to see this right because I don't carry this one put in place of this one. So you go see say the one where I know the work, right? Know the work to give me this particular, to give me any of them actually, because the confusion only for the program now. So make I do the correct thing now. Now I come here, put for start light. So at least they show now say the thing don't reset. Okay, so again, I go like reset them, stop and start. And then if I go back to FactoryIO, I stop this one and play them again. If I press play here, okay, you know still work, make we know what be the problem. It even good self say if you know do if you know work like this, more see more troubleshoot more and see what the problem fit be. So if I go back to that my code, make I see what I write there will make it no work. So I see start, stop, reset. Okay, no. Now the function, the SCL now one click. Okay, they give me error here, right? They give me error here. They give me error there, and for all these other places. So what you go just do be say, I go say, I compile this thing at all. When I compile, and that means I don't even read the message where you gave me before. No, we know what be the error message where they bring before. So I say, I compile. So we'll see what be the error message where the thing they give. Instead, when the output parameter reset is read, you do not assess the operand that was transferred as actual parameter, but rather only the former parameter. Okay, make we see this grammar too long. But let's see if this one is now the output parameter they reach. So make I read the one we get, make we read the light, their one. That is here now reset lights. So make I read reset light 1. Make I read reset light 1. Here make I read stop light 1. Sorry. Make I read stop light 1. And then here make I read start light 1. Now why they change them to this thing to say the ones where I actually pass values to are the one, are the static variables, right? So this one's just be like secondary things. When I say take value where I don't really give. Again, that's how I want to explain this to you now. So the ones who I go easily read, right? In this I no get access to this stop light, start light, reset light will be output. So make I read the ones who I believe I will get access to. Will be my stop light 1, reset light 1, and then start light 1. So I go save this one. I go compile. And then I go re-download them again and try one more time. Again, I don't make the same mistake what I made before. I know they check whether the thing don't give me error message or not. But let's just try. If you give error for the compilation, then we can always come back. But most times if you give error for compilation, you know, agree you download. So maybe na there where my confidence they come from. Alright, so I go need to reset again. I just reset so that we go there on the fresh page. I go need to stop this one and start this one. So if I press play here, it still no come. Wetin be the problem again this time? Make I recompile this thing and see wetin the thing they talk this time. Okay, say it was successfully compiled, 0 warnings and 0 errors. So why the thing no come? Why the thing no come? Let's monitor this thing and see. Let's monitor this thing and see. Okay, so come error full everywhere. Make I go offline and recompile this thing again. Make I go offline and recompile this thing again. May I go my device configuration. Make I re-download, recompile and download. Go recompile. And then I could just download. So I just recompile the device configuration, and then I re-download them. So I just download everything with the inside. Sometimes a problem as minor as downloading, now it be the problem. So let's try and see. Okay, somebody they say my reset. I don't reset. So I don't stop it, so I don't start them. So if I press play again, the same problem. Make I see whether this time if I monitor them, it go Greek monitor, where monitor they again. Okay, for here. Monitor this. I see. So everything they work well for the compilation now, but I think you see my start lights. This is the result here is false. Which one be true? Stop lights is true. Okay. I think see I don't see where the problem dey, right? So I don't see where the problem dey. You know, see this stop light, I tell you, say this stop light na normally close button, right? So if stop light is equal to true here, me say you don't press stop light. You don't press stop light, and you never press stop light. I mean, as if we say if it's like this, it means say you never press stop light. So what I go do now be say, see. You say if you don't press stop, if stop light is true, but you know, as na NC as na normally closed button, it's already showing true. So before you go press, if you press and now you go first. Before you press them, it already dey true. So without pressing, this condition where they here, they already won't hold, right? So what I go do here now be say I go say if this one is equal to, I feel say 0 or false. So I feel say false. If this one over here, they equal to false, right? And the start light they true. So when it be say it dey false, when it be say it dey false, now I want this thing to actually work. Okay, so save, compile, and then I go download. The video. Okay, so I will need to reset. I don't download them. Yes, loading completed. 0 error, 0 warnings. So move check here again. If I stop this one, start them. I press this one. It still don't work, Baba. I better check this in properly. Okay, I don't see what's in the problem here. The problem be say for here, you see here where in the who they talk all this who say if start equal to 1. Yes, okay, I'll later put start equal to 1 here just during the troubleshooting, but I'm going to remove it now. It doesn't really matter. This one I left it like that, so this one I can remove it. I just check. I was checking whether it was a problem. This one is necessary for me to actually state. I don't want through, I want maybe false. And I think I don't already explain why. Okay, so see here now. You know, see the waiting I can add again. I say, if all these things know they happen, there's another condition. You know, say for the starting, we say if you press the start button and the reset light they on, right? But if you just start this program, or for here itself, we say if you press the reset button and the stop light they on, or for here we say if the stop light, if the stop button you never press them, you press them rather, and then the start light they on, may you do all this. So, but the truth of the matter we say if you just on this program, every light they off. Every light they off, that be the truth. So these conditions no go ever work. And I make what with the present since they work. So we think what we can do is say we can create another condition. Say if maybe I should just start the program, the start light, of course, start light 1 value will still be 0, nothing will happen. And the reset light value also be 0. And it means say they never press the stop button. Right? It means that means when just on this thing, nothing don't really happen. So what I want to do that time, I want to make the red light they show. We used to do the same thing for the ladder logic, right? In fact, I will show you before I end this lecture. So you go see say the start light now, I don't make them equal to 1. The stop light, I don't, of course, not like we did do before. I don't force them equal to the start light. I don't force the start light 1 equal to the stop light. So inside the stop light 1, inside the stop light. So the issue now here be say, I know say if I just start this thing now, I always like when I on this thing, you see this place. So I like to reset these things back to their start values, right? If you see value within the here, you see reset to start values. So if I reset to start values, my save, compile. Because remember I said our static variables, those function block where they use. So this function block where they use, remember not the function block diagram, now function block. This function block where they use, it is store values. So if you know reset them to initial values, if they get something where no they are outdated, so I want to reinitialize it, right? I want to reinitialize it. Then I can now say that. So if you like, I don't really do them, but if you still like mass, do this one like this, stop and start, and then go back to this one. So if you start this thing, you see say the red light, they always they on. So with this red light, where they on now, you see saying that this condition, you they meet. You see saying that this condition, you they meet, they come. See what happen now. Since you don't see this start light, no value yet. This one no value yet, and this one no value yet. Let me input 1 equal to start light, and then of course here. So see what you can do now. Since you know say they meet, you have stop light 1 equal to 1. See here now, we am be true. So the only way if you do not have to press reset, make everything where they here happen, right? If you press anything will not be reset, it no go work. For example, if I come press start, of course it no go work. If I press and stop, of course, now the same stop with the press, so you no go still work. Now the same thing, yeah, we done the since they did it. So the next thing we go happen here now reset because say this one they on. So if you press reset, they say here is true. If you see this reset, go do all these things within inside here, right? So if I go here, I'll press reset and off this one on this light, right? Even if you press start light back, because the start button now, if you press the stop button now, right here I don't press that, but not be start light. I say start light, this is start light they on before I go work. So because then a yellow light they on, no go work, right? So you need to press this one, of course, and go off this one, on this one, and then you should see the same thing will get if you press your start back, you know go work, right? Until you reset. And then you see that the same thing we don't do here, we don't do for what's the other one name for ladder logic. Now we don't also do for here. So these things not be now it depends on the program, programming language we want you to write your code. Some people go prefer to write them with this way, some people go prefer to write them with the other way. But for this particular program, it doesn't say if I want to do this thing now, it go be easy for me to just go ahead and use ladder logic and do my thing, rather than coming here and be saying if this one happened, the other one no happen, the other one no. But again, I'll be a maker. Another person now if you do the same as Timothy, Thomas, Isaac, whoever, you could do this thing yourself, and then you go say okay, now this one you like, who knows? So anything where if you say like, just go ahead and do. Okay, I thought I could do one last thing. Make I just drop this one for us before we go. If I go for this our ladder logic, and I want to do that same thing for ladder logic, so what thing I go do here now? I go say this is your stop network. So just between your network 3 and network 2 and network 3, I want to create a new network, insert new network, right? So I'll get a new network, will be network 3 for before I'll get my actual stop, right? So here now I want to write that same thing where we say if this one no dey on, this one no dey on, maybe saying a stop light go dey on. So it says I go take down for ladder logic now. I will come say if this one is this one dey here, they come. So what I could just do, say if this is your start light, right? So if your start light dey off, this thing will remain closed or open. If your reset light dey off, this thing will remain what is it? I want to say if this light no dey on, this light no dey on, maybe say that this light go dey on. Okay, now first put this one, this is your stop light, right? So if this light dey on, I'm go close this one, close this one. So let me leave it like this. This one's supposed to be closed, and then this one's supposed to be closed. So now if this your light no dey on, this one will remain closed. If this your light no dey, so reset light no dey on, this one will also dey closed, and then signal will come to this your stop light. I don't do the same thing. So see just one line of code. Now I take write all this Baba thing where I write for this place with that one. All this else if where I write here. All this long thing where I write here. Maybe this thing what I just do here simply. Say I put normally close, instead this with another one, and then it does. So all those long grammar, I don't write here with ladder. But not be say ladder go fit do everything. It gets on ones where you go reach, like I said before, you go see say ladder no go give you waiting you define. Okay, so might just go for menu B1, call that one back. This video don't too long, eh? So might just call that one back for main OB1. For main OB1, and then for main OB1, I think this one. Stop this one. So I will need to rename them. I will need to add their name back. This is start button. This is reset button. This is stop button. This is start lights. So this is reset lights. I don't go put start button here. Start lights. and then for here I want to put stoplight. So you see say so now your start light, your reset light, and your stop light. So I go save this one, compile this, then go be to download them. My system don dey try now, so may not too laugh at me. So I go hit this one load. So again, I go need to reset this one. If I go back there, you go see say now this one they will stay for me. So normal way, if I press one, it no go work. I go press this one. Now if it stop, of course nothing. So I need to press this one. Oh, I press this one go come up for this one. So maybe I think we get something is not proper here. So more check. We go don't miss. But first of all, we'll see this may not be one. Make we see this may not be one. We'll see stop light, reset light, start light, and then everything. Okay. Oh, see the start button. I don't go put start button here instead of stop button. So that be the problem. Right? So this one has stop button. So that one has stop button there. Okay, so I go need to stop, start, and then I'll show you FactoryIO. If you reset this, you know if it stop, and then if you play this, see say stop this one, then this one stop this one, this one stop this one stay, if it stop, you know if it starts until you reset. Okay, so now the thing I want to show now be this one, So anyone way like, just go ahead and choose. Sorry, say the video don't too long, but of course I just needed to do all these things, and then so that you will see how much the thing declare. If you like this video, just give me a subscribe, and then also like the video. If you recommend them to also other people too, we need to understand the same matter. I'm going to bring you videos like this for Pidgin, just like I said before. You know that sometimes you go to explain this thing, but the problem not be say you know explain and well, but you know speak the English well. So now here we will stop for today. We will see another day. Thank you very much.